Okay, yeah, thanks for being here and staying this late. Actually, I drove most of you guys out of the room, I'm sorry. So I'm talking about a platform that we are building for collecting actually data. Usually these days this is done with these type of devices, but actually for collecting Nautic data that's not possible. So we are building a platform for this, and this is what I'm talking about. So I've given you an overview and a motivation why we actually do this. What needs to be done with respect to data collection and data processing, although we focus on the first part of that. I talk about the hardware setup, requirements, features. I have a little block diagrams here and device selections we did so far. And in the end, I show the project status and the next steps that are coming up. And then in the end, there's a small wrap-up. So let's start with, you all are sailors, right? So I don't need to talk about this. Who knows Nautic maps and has seen one? Well, that's a lot, kind of half of the people. So I just quickly walk you through. You probably don't know this one, but actually this is easy. So you have those lighthouses that have multiple sectors with different colors. So you actually know where you kind of are. There are a lot of different types of buoys scattered around, and the most important thing for sailors actually is that you don't want to drive on ground. And this is here, those lines and those marks here are marking shallow waters and stones that are somehow hidden beneath the sea level. So this is very important information to actually safely sail through waters. So now, why do we want to do this? So let's have a look at the current state of OpenSeaMap. This is how South Manhattan is currently looking. And this is a NOAA map of it. So here you see much more detail with actual depth levels and shallow water areas here. And a little bit better it is here in the Kiel area. So we have the lighthouse of Kiel on the top right corner, and another one here. And the most important areas where you usually go are the big traffic goes is this one, so it's also marked. That's quite interesting. This is a current updated chart from a real provider of these charts, and so it has much more details, especially these very detailed depth information where we can actually see if I have a vessel that is like 2 meters of depth, then I shouldn't actually go in there, because here is a 1.1 meter mark and I will get on sand and probably don't go on anymore. And well, this is also an OpenSeaMap map, and it's actually pretty good. So somebody, however, donated a lot of data and actually painted depth maps in here in Lake Schwerin. That's pretty interesting, and it's I think one of the most detailed map that is available currently on the whole project. And yeah, maybe that's actually official data that has been contributed. We are not sure up to now. Maybe, but actually, so there are also other projects for this. Kind of the equipment manufacturers try to build a community-based charts. And all those fisher guys that really use very good equipped boats, they are scanning around for these areas, especially these where you have large drops in the water, depth drops, because that's where the fishes hide, and they like that because the stream goes up and down, and that's where they have fun swimming around. So fishers also like that. So what's our target? The target is to get good maps from OpenStreetMap, and so that we can use it at least for trip planning, maybe not for actual decisions when you're going around, at least if you don't want to risk your boat. We focus on the data collection part for this time. There are a lot of more issues like data processing, algorithms, and data visualization. Especially with crowdsourced data, you don't know when it has been raised, right? Somebody drove here and collected some data, and this was like 2 years ago, and now sand came here, and you have a new sandbank, and everything changed, and you don't know if the data is now available and how these lines have been calculated, if this is still a valid information or isn't. But this is unsolved for now. Let's first start collecting data. So what needs to be done? Well, we have a lot of information available on such boats. A lot of people have echo sounders for measuring depths. They have GPS signals. They have gyro data for their positioning, tilt, and so on. They're usually also connected on the boat to an NMEA bus. That's kind of a CAN bus-like, so a controller area network, which is also used on, I think every car has at least like 10 of those buses. So it's a standard thing, and a lot of other equipment is connected to this, like loggers and chart plotters, and you can visualize everything and also record that. However, the problem is getting the data out. So like Raymarine, they have the community project for building good charts that are kept up to date by their users, but they obviously want to have those data for themselves. So there is no real exchange format for this, so we need to do this on our own. There's some metadata also involved about who is the contributor for licensing issues, for example. The type of the ship might be interesting for post-processing the movements, the type of devices, whatever is needed for actually processing the data. Everything kind of flows together and then is uploaded to a server where it is actually processed. And this is the flow. That's the kind of an overview and what is available right now. So there has been an OpenSeaMap hardware logger for that, but unfortunately it uses an old school NMEA 01A2 3 format, which is kind of abundant for now, so there's almost no equipment available for that. At least the new ones don't use it anymore. There is a Raspberry Pi logger. I show that in the next slide. And there's GNUBoat, which is this project. Then there are some proprietary solutions. Well, proprietary solutions, we don't like that, right? Let's go on. That's the NMEA 2000 logger. So this is, you know, those standard boxes. So like this size and in the depth, it's kind of big. So you don't want to have this on your boat, actually. But for a prototype, that's quite okay. And that's where basically things start. These are actually those CAN 2000 connectors there. So let's go on. The hardware setup has some requirements that are not so used in usual hobby projects, because we need a very tight integration. We don't like big devices, we want compact devices. And we really need easy to use things, because most people are just boat lovers. They want to sail and they don't want to hack around with their devices. They just plug into the board network. We need automated data collection and so on and so on. Partially automated upload procedures, and we definitely want an open source design, because things change and we want to adapt that and want other people to adapt it as well. And we do want to add more other sensors also. So we can provide some more features, actually. So mooring is very interesting. So you put an anchor and now you're going to sleep. But what happens if weather conditions change? You're drifting and so on. So you can now also include those things. You can ring the alarm bell, send push messages to your smartphone. And there are other parts as well. So one of the most critical challenges is actually power supply, because the boat power network is behaving the same as a car power network, and it is really bad. And that kind of delayed the project and still delays the project. We are still working on that. You partially need backup battery or standalone operations for sailors, and yeah, CAN interface decoupling may also be an interesting part. So this, for example, is a standard power supply rail on a car. Usually have like 14 volts, and then the engine starter goes on, then it stops again, then you have noise from the generator, and so on. People plug it in reverse, that's also interesting. And you have to survive, basically, all those scenarios. So here we have a highly overview about the power supplies. We have a power grid on the boat with a lot of generators. Sometimes we don't have any, and just a battery, also fine. It's an easy way. We have a filtering. We have multiple cascaded DC switches for supplying all the supply rails we need. Then we start with an open source or kind of open source device. And we use all the sensors that are available anyway. We have wind metric sensors, GPSs, AIS, that's a identification system for vessels on lakes, in the sea. Echo sounders, whatever is present on the bus, which we need to connect to the Raspberry Pi using CAN interfaces. And then we add some local sensors that are put on top of the Raspberry directly for motion detection and later post-processing correction of the data we collect. Basically, the boat moves, and if you have a depth that is like this, it definitely is a different depth than the boat would have been upright. So you kind of want to know how the boat was when you actually measured the depth. You definitely want to know where you were when you measured the depth. And then you might want to have some air pressure for weather condition monitoring or whatever. We also supply some wireless connections. One is serving as a hotspot, so we can connect to the device's network with our mobile phones, for example, and have some nice GUI. And the other one is that the system can connect to other networks, maybe acting as a proxy for in the marina wireless network, or you can upload data with it to the internet, whatever. So basically, we kind of built this shield here, this head for the Pi, and this is connected to what is present in the boat anyway. So we have a lot of devices to select. For the single board computer, we were going with the Raspberry Pi. It was available. It is widely used. There's a lot of support for that, and it's a highly active community, so we like it. The CAN interface is an important interface. We selected some microchip devices for that because it's also widely used. There are reference designs available like the PyCAN 2, which we actually use. I show that later on. And it's also well available. We just heard the talk about availability, so that's fine. We like to add the barometric sensor. This is quite good, reasonable, accurate. Also available, that's nice. GPS system, we actually didn't really selected it yet, but these are some candidates. We want to use the module because we don't like to do RF routing on our PCB, so let somebody else do it, who is hopefully better with this. And we need definitely an external antenna because this box is probably mounted somewhere in the hull of the ship, which might be metal. Yeah, the IMU is also not yet selected, but a good candidate is the one here because there's also prototyping available, and at least DigiKey has some of those available. Yeah, the wireless interface, it's generic, it's a USB interface, so we just need driver support and hotspot support. That's basically it. We kind of delayed the whole project because of we do something else for daytime job, and it was a lot of things to do during the last months. But we did do something, and we built a prototype setup, and that basically uses a echo sounder. Irma is basically the only producer of those, so independently of who actually prints its name on it, it's usually one of those. And we used an old Raspberry Pi and a PyCAN 2. We built some power supply switches here and then connect everything together. That's it. So that's a very small boat, but you noticed that probably. So that's the Echo Sonar. We have a little USB hub. The Raspberry Pi is down here or got out there. Well, it's a remote controlled boat, so we have some stuff in there which is not used by us actually. This is the software stack, which is completely available and running and open sourced, and the website is somewhere in the back. So we have a configuration that's automated, deployment is automated. We have daemons that take care about the data, and we are logging everything, and there is a nice web client. Yay. So the next steps are, actually, currently we are running a demo. That's nice. We are kind of through block level planning. Power supply planning is in progress. We actually currently build a battery health monitor which integrates a power supply and also the CAN interface, which can be reused for this project, or actually this is part of this project but a different task. And we need help. So please, if you now think, yay, that's a nice project, I want to support it, here we go. Let's have a talk later on. Yeah, wrap up. We want to do this. And to test our stuff, we need this. And then in the end, we want to do this. Thank you very much for staying here. Questions?
Did you use the thing you drag behind the boat to compensate for the angle of the boat?
We drag something? Sorry, the question was if we use something that drags behind the boat for compensation.
The yellow thing.
Well, actually, this is two completely different pictures, so maybe a little bit misleading. This is the remote controlled boat we currently use as a test system, and which kind of can be used in areas where you don't want to drive with this because of shallow waters. But
But if
no.
you drag that behind your sailing boat, you would compensate for the angle your boat would have.
I think this one is actually more affected by waves than this one, so it's a lot more. Yeah.
If you sail on the sea, then you have ebb and flood. So do you use the GPS height data to compensate for that?
That's one of the questions that is related to the algorithms for post-processing. Definitely there has to be some compensation for current sea levels. So even on inshore lakes, you have changing heights, so it definitely has to be, especially there.
I mean, it's different, but the accuracy of the GPS height level is not that...
Probably is not enough. So maybe we need to use other sources for that. Yeah. So the question or comment was that there are boats that are built with buoys. Okay, yeah, buoys built with accurate measurements. Yeah, I know some of them are used as precursors for like typhoons or something, and other wave things that are going across. I don't know if they are public.
I guess you can also use the tables for finding out what the level will be, but this is completely
Yeah.
different.
We have, okay, one question there, and there, and then there, and then here.
Have they tested the accuracy of the data against bathymetry data?
About so is the data tested against which data?
Bathymetry data that's actually collected with sonar.
Not yet, no. So it is not tested against any other data right now.
To repeat the question.
Yeah, okay.
Sorry.
There?
I wanted to set up a setup like this and pretty much constantly feed the data out. How much would I need to do? Like, let's say, the coming sailing season.
Yeah, the question is if what has to be done for continuously transferring this data to any server, right?
Well, also, basically, how much time roughly would be involved with building a setup like this, putting it in my boat,
So this setup, right now, I would say like not a day, because you basically just have to buy stuff, hook it up together, and then run the software on it, which is available from the website.
As long as I have internet connectivity here.
Yeah, and be careful with the power supply. So that's not designed for actual boat power networks.
Okay, we have one question.
Yeah, there's a Dutch project I was involved with, which actually uses inland shipping boats, connects your GPS on the phone, or on, effectively does the same, and then also run some checks against the telemetry data to see what they connected. So I'd like to introduce you to that if you have some time afterwards.
Yeah, great. So the comment is that there are a lot of other projects going on in this area, and we will hook up later on. Thanks.
So Al and
You may have answered this and I missed it. How big is the yellow one? How big is the yellow one?
The yellow one, like this. So this is the size of the small yellow you see there, the small yellow boat. So it's a toy.
Asked for support. How do you imagine to get remote support for hardware?
Remote support.
Ideas about that?
So basically, it's about the question is about how we can provide access for the hardware. So right now,
No. How you can get support remotely for hardware. For software remotely is never a problem, but for hardware it seems more difficult.
basically we check the schematics and everything into a Git repo, and then you can work on it, and then we can sort it out just like software.
You have to put a sponsor on it and get some money.
On the tiny yellow thing, okay. Who wants to sponsor a logo here? It's a nice thing. It's very good visible, and we will also travel to whatever it needs. We will. No, okay.
any other questions? Okay, thank you. Oh, sorry.
So I have I haven't been from the beginning, but this project is only for OpenSeas or also for the rivers?
No, it doesn't depend. It's for both. So it's basically for all the shippable areas, or not, also non-shippable areas where you want to know about depth. Yeah.
Have you tried with proprietary interface instead of NMEA 2000?
Well, NMEA 2000 kind of is a proprietary interface, so you actually have to be a member to get official knowledge about the messages exchanged. There are libraries that know about that. Yeah, if you know what is the message about, yes.
One last
That's
How confident are you with a USB connection in moving all the environment?
so the USB connections shown here for the wireless types would be. Yeah, so basically everything is mounted, will be mounted in a mechanically sealed thing, and the wireless and USB interface would be in it. It's not externally accessible. So just the network interface will go out, and RFs.
Okay, let's thank the speaker again.
Thanks.